the 533 SwitchBack. So this video is going to be a quick assembly guide for the frame itself, and I'm also going to be showing you how I have everything set up on the frame here for the 2020 racing season. So let's just go ahead and take a look at my finished build right here. So obviously this is the frame here, the 533 SwitchBack. So let me just give you a quick tour of the quad so you can get a sense of how everything is working here. As you can see on the bottom, we have the pretty standard nowadays, the 3 motor mounting holes here. This little cutout is something special that I'll get to once we assemble the bare frame, but you just have your 4 arms that come into the center. I like to use the 2-screw mounting method with the 1 flush and the 1 extra. I'll explain more about that as well once we get further along. I don't have a battery pad on this currently, just have my crossfire across the back here. 2 tiny LED 5-volt LED strips, so I can change the color of my lights for racing. And then into the center we have an iFlight 20x20 ESC with the tiny LED Unity flight controller, which houses the Nano Crossfire underneath and the Nano Unify 32 up top, which just goes to the TBS antenna with a Foxeer Nano Predator up front. And then the motors are the iFlight Sing 2207 1900 kV, these new red editions that just came out. So for a quick dry weight on this guy, almost 100% ready to fly. The only thing that we're missing obviously is props. You can add about 20 grams from that, and then a 3-gram battery pad. And now this is not the lightest configuration possible. You definitely can save a decent bit of weight. Obviously we have LEDs, full steel hardware, and extra hardware. Let's go ahead and put this guy on the scale. It's coming in at about 261 grams, which is about 50 grams lighter than my previous setup. So that was just a quick intro with my completed build. So let's go ahead and assemble the bare frame and see what it has to offer. So for the frame kit itself, it all comes nicely packaged individually in plastic. You get your 4 5mm arms, your special little wiggle plate here. You get your 3 3D prints, the turtle stick here, the little SMA mount, and they have different versions of this if you want to use your RX antennas or not. And then the nano-only camera mount. That is one thing to note. This is a nano-only frame, and you can choose your angle. You can see I'm using the 50-degree version. Here's your top plate. Here is your bottom plate with the countersunk holes to make the flush screws on the bottom. Here is your mid plate with all of your press nuts, and as you can tell, it is identical. A lot of the things with this frame is completely identical. It is a true X, which is pretty nice when building it because you don't have to worry about front or back, and everything works the same. And of course, with the rest of it, we get our hardware, our standoffs, and all our screws that we're going to be needing. So to assemble the frame, you want to start off by taking the normal button head screws here, and you want to take this wiggle plate, and you're going to be screwing it into the bottom of the mid plate up through here. Goes right through, and you want to attach these standoffs. Just go ahead and put all 4 screws through into the standoffs. And it would be a good idea to use a little bit of Loctite here since you're going metal into metal. For right now, I'm going to gently make sure these are all as tight as they can be with a set of pliers to hold the standoff here. Okay, now that that's done, we can pretty much see what's going on here with this wiggle plate and the genius of this frame. So normally frames would just have a single plate and then the arm, and then kind of, it depends on the order. We kind of move from a sandwich to a single, back to a sandwich, all kinds of different designs. But the recent designs use an aluminum plate which has milled out channels. And now the problem with aluminum is that obviously it's soft, it will bend over time. So you can't use carbon for that because if you mill it out, it becomes extremely expensive and extremely weak. But the genius of this design is it's just a separate insert that goes on here. So it acts like the milled out aluminum plate, but now it's made out of carbon. So you can see we're just going to take our arms and they're going to slide right in here. And now the tolerances on these are actually extremely good. I just pushed that in. The only thing holding this is friction, and it is in there solid, absolutely no wiggle with 0 screws. Just slide them right in, and this is why it's important to screw this plate down first, because you don't want to put these in here and then try to force them down. You can end up cracking the carbon, so make sure you do it in this order. There we go, I pushed all the arms in, and that is the locking mechanism there, and that is one of the main reasons that I love this frame so much and why I'm choosing to use it. Then we can take our bottom plate, which is once again symmetrical, and this is just going to go on here. You can line this up and get things screwed down. So I'm just using 4 of the shorter countersunk screws that are supplied and going into the outer arms here, and they're going to go right up through the plate, through the arm, and then into this outer press nut. Now if you didn't notice, it's using a slotted arm design with the one outer screw that is fully attached, and then this one is simply a slot if you choose to use it. So it is one screw arm removal, so you just take that screw out and loosen this screw if you're using it, and you can pull that arm right out. You can see how tight the tolerances are, and then slide a new one back in, and you are good to go. There we go, we have all 4 arms screwed in. You can see the bottom plate is flush as it is made, and that is where the main structure, the main strength of this frame comes from. So I did mention before, and if you aren't aware, this frame was actually made and designed by Evan Heads Up Turner, who just recently won the 2019 Multi-GP Championship, and his good friend Mondo, who worked at Boeing as a mechanical and a structural engineer, which definitely makes sense because when you hold this in your hand, you can just see how elegant the design is for being extremely lightweight and extremely strong at the same time, with really, really good engineering design choices. Now, moving on to the center, there is a press nut here on both sides, and that goes to this countersunk screw, and as you can see, there is nothing here. And now this is actually done on purpose. If you put a screw through here, this guy tightened down, hopefully you can see this. As I start to tighten this, I'm not going to crank it all the way, obviously, because you can crack the plate, but applying just a decent bit amount of pressure, not sure if you can tell on camera, but you're actually meant to bend this plate just slightly, because not only does that tighten the center, it's going to tighten up the arm channels here and just remove all other slop and just make it even more durable. And now for my build, because of the ESC and the way the things and the way the components fit on the bottom, I'm actually not able to fit these because of the press nuts are too high, but that's not an issue. Even when I take these out, it is still extremely rigid. But that's just a quick note that these are meant to be slightly bent, to slightly bend the carbon plate on the bottom there. Obviously, don't screw it down so hard you crack it in half, but that is a nice extra feature. And these holes out here work as your 30x30 if you're going to build that. However, I would suggest against it. You can use this frame on 30x30, but it's going to be an extremely tight build, so I would recommend 20x20. In the center, we have press nuts for 20x20, and they do give you long steel screws to help go up through there. However, I'm not a huge fan of this. What I do actually is I take these press nuts and move them to the 30x30 holes. So how I do that is I just take a random long screw here, just thread it into the press nut from the top, take my pair of pliers and just pop it right out, take it back off, and then move it to the hole I want and get it lined up as best you can. Now obviously it is best to use a proper machine tool when doing this to set the press nuts down in the holes. However, I find just using the force of a screw works pretty well, and I've had them line up fairly straight. I haven't had any become majorly off axis when I put them in. So just putting the screw up, as you can see the press nut is out a little bit, and then as I tighten the screw down, it forces it into the carbon hole and sets the little spikes on it. Tighten that as hard as I can, and then I back this screw out. So I take this guy all the way back out because I don't want to be using that long of a screw there. And there we go. Now the press nut is moved to the outer hole. Okay, so I went ahead and moved all of the press nuts to where I wanted them and just put some extra 10mm screws that I had through there. Now keep in mind, this is not the intended way to run it, but I just like to do it this way. It just gives me peace of mind knowing that this is just going to be insanely strong now, considering it's already plenty strong using just the one bolt. And then in the center, I've gone ahead and put in some nylon screws through these little pass-through holes with a nut there. Now I know they do include the steel, and a lot of people use these. I just like to use the nylon because the stack is the most sensitive part. So if the quad gets absolutely crumpled, I'd rather have all these bolts break and hopefully save the electronics rather than a steel bolt going through them and just ripping them apart. That's just why I use those. And in a frame this stiff, I don't think there's going to be any issue with that. So let's go ahead and talk about what these holes on the outside are for, these rectangles. They are for these side force generators. So this is pretty much a traditional, in the sense, style frame with just normal arms. Now there are box frames which have vertical arms here, as well as vertical connectors. And a lot of people say, I mean, it's pretty well known that they fly differently. They definitely turn differently. So what these are for, these are optional. You have this little piece here that goes in. This piece slides down through on both sides. You take your 8mm screws and they just go right through here into the press nut on the side of the side force generators. That's what these are called. Once again, these have very tight tolerances, just like the arms, to make sure things aren't flopping around. And there you go. You could see there is a little cutout for the motor screws. They did not forget that, which is a good thing. And they sort of go on the inside towards the center here. And you can get a look at what that's going to do. So this pretty much acts like the vertical frames do when you're turning. It just gives you sort of a knife edge through the wind. It's kind of hard to explain. I know a lot of people say it flies a lot like the simulator when you are turning. So that is really, really nice that you can get the benefits of a box frame and still a really light package. Obviously, this is going to add some weight, but you can still keep the non-hassle of a normal frame, since box frames typically are a lot heavier and a lot harder to work on, since they have all kinds of pieces that slot together, etc. So this is a really, really cool idea, and they do have an even larger version, a thicker one, that you can also try. Now, I haven't flown this yet, but I'm not quite sure if I'm going to use these or not. I'll definitely have to try them out. Not only will they help with the turning, but they are going to add some durability as a brace back-to-back, as they are extremely tight tolerances. You can see there is like zero gap between there, so it's very rigid, and it just takes the stiffness of this frame from a 10 to a 12 out of 10. And lastly, we can go ahead and put the top plate on. The section with this part is the front. It's a little bit misleading. I actually made this mistake at first. This sort of looks like the typical front of a quad. However, this is for the rear, for the antenna to come out and mount like that. So I'm just going to go ahead and assemble this bare without the TPU parts to get a weight on it, since that's how I usually weigh my things. So we'll just take this here, and keep in mind that I do have the nylon hardware in there that probably adds about 2 grams, as well as I am using the extra countersunk, or the extra press nut here, as well as the extra screws. So that's probably adding at least 5 grams total, and those are optional. You don't really need those. So let's go ahead and put this on with the other 2 screws. We're coming out to 63.57 grams, which is definitely very respectable for how insanely stiff and strong this frame is when you feel it in your hands. And now I know you definitely can run it lighter by removing those extra things, as well as using aluminum screws for the center, not the arms. You still want to use the steel for those, but you can use aluminum for those, and you can get it down to about 55 grams. And then adding the side force generators here, the smaller versions, is going to cost you about 8.5 grams per side, so it's going to be about 17 grams extra total, which definitely is not a small amount of weight, 17 extra grams. However, Heads Up has said that when he's flown it, it just flies so much better, you don't really notice the extra weight. So there we go. That's pretty much going to do it for the frame assembly. This took a little bit longer than I expected. There's just so much to know about this frame. There's just really solid engineering that I didn't want to skip anything, and I really wanted to give credit where credit is due here. Now, obviously, for the TPU mounts, the VTX one, this one just slides right over the back. You can see it has square holes there. You can see it here. It slides over, and then the screws stop from coming out. The front turtle stick just goes through the screws and sits there with just the 2. And the camera mount just slides down over the standoffs. And if you're having trouble getting these on, the tolerances are quite tight, you can go ahead and use a hot air gun and just warm up the TPU because it's stiffer when it's cold. So just warm it up a little bit, and you should have not too much trouble getting these on. So there we go. That's that. So let me just pull this other guy up, and we can conclude the video. So you're probably wondering why I'm switching to this quad when I have my own signature frame, the Nexus here. I came out with this frame about a year ago now, and that's sort of where this all starts. Now, when we started designing this, things took quite a while, and then production, and blah, 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 and things just take longer and longer. By the time this actually got released, it was perfectly fine, and I used it for a while, and I've flown these frames so much. I have like 10 of these guys, all in different colors, and they have treated me very well. There was a couple weak spots on the bottom plate that we wanted to address, as well as using the pod and the frame overall, which is quite heavy. This setup dry was about 300 grams, so I definitely was looking for something lighter. And I was actually in the middle of a redesign for this frame when the SwitchBack came out. And then I got to see it firsthand at the Multi-GP Champs, and I looked it over, and it was just exactly what I was trying to do. Obviously, I did not have the wiggle plate. That just exceeded my expectations. But everything that I was trying to do in the redesign to make this smaller and lighter and more durable was done here. And there's no point in trying to copy what they've done, as well as I know Evan and Mondo personally, so it is a great idea to help support them. So that is why I'm switching to this frame here. Not only did I switch the frame that I'm using, but I switched the antennas, the flight controller, the ESC, the camera, and the motors. I literally switched my entire setup. Now it is still pretty similar. You know, you can't get that much different in setups, but I will be going over that a little bit more in the build video for this guy here. I'm going to be building on this frame and recreating this guy here because this is my new setup, and I'm going to be cloning it just like I've done my Nexus setups using the Synergy flight controller. So yeah, that's pretty much going to do it for the 533 SwitchBack review with assembly guide there. I apologize if this was a little long, but I just had a lot to say about this frame. Another great thing to say about it is that it is only a $50 frame, so you're definitely not going to be breaking the bank on this, and the quality overall is very, very good. There's no chamfers on the arms, but you don't really need them in a race frame, especially when the arms are the main thing that you're going to be breaking. It is available in US and European warehouses, which is very, very nice. If you're overseas, hopefully it'll be easier to get one of these if you so wish. There are links down in the description below to both of these. I'll list the US and the EU versions. And of course, they're selling the side force generators and the spare arms and spare parts on their site. So yeah, that's going to do it. Thanks for watching, and I'll see you in the next video. Bye.